Our aerospace curriculum
Hello, dear children. I think now most of the students have joined, and I could see some students raising their hands. So, if there is anything to communicate, yes, good evening, dear children. If there is anything to communicate, you can make use of the chat box available. And yes, I'm really glad to welcome today's faculty from the Aerospace Department. He is Dr. Balaji Ramakrishnananda. I would like to give you a brief profile about Sir before welcoming him to today's session. He currently serves as an associate professor, and he is also the vice chairperson in the Department of Aerospace Engineering at Amrita Vishwavidyapeetham, Coimbatore campus. So he is really passionate about teaching, and his current interests are UAVs, the bio-inspired micro-aerial vehicle designs, computational fluid dynamics, etc. So he has completed his BTech in Aerospace Engineering from IIT Madras and his MTech in Aerospace Engineering from IISc Bangalore. He has worked as a scientist at National Aerospace Laboratories in Bangalore. He obtained his doctoral degree from Nanyang Technological University in Singapore, and he was working with the defense sector there in Singapore. Then he returned to India and worked in, I would say, Wipro AMD, and then he has joined Amrita. I'm really happy to introduce Dr. Balaji Ramakrishnananda, who is having a lot of industry experience. So welcome you, sir, towards today's session.
Thank you very much for the introduction, Ms. Lakshmi. I look forward to interacting, having this very fruitful and exciting discussion with students. I'm really welcome on the behalf of department.
Yeah. Thank you so much, sir. Thank you for coming also. Thank you for being here. Thank you for being here and interacting with our kids. I'm really happy. So before we start our discussion, I think all the students who are here are really interested into the aerospace engineering. So I think our session will start with giving them a basic idea about aerospace engineering, the relevance, and maybe about the opportunities and ideas. So sir will be giving you an idea about all this in detail. So students, please be keen, attend all these details because this is going to be very, very important when it comes to your career. So over to you, sir. I think you can just share the screen.
Thank you very much.
Now questions have started coming. So yes, we'll be addressing almost all your queries, dear children. So yes, sir, over to you.
Yes, thank you, thank you. I'll share my screen. Are you able to see my screen?
Yes, we'll be addressing almost.
Okay. Are you able to hear me properly? Hello?
Yes, sir.
Are you able to hear me?
Okay. Yes, yes.
Sure. So welcome once again. That's our Chancellor welcoming you on our behalf. So welcome to the Department of Aerospace Engineering at Amrita. So we are always, you see some sound in a Sukhoi Su-27, which is an aircraft going at a speed of Mach 2.35. Mach number is actually speed of anything divided by the speed of sound there. So literally speaking, the ground speed is 1,550 miles per hour, which translates to around 2,500 to 3,000 kilometer per hour. That's a very if you put your thought to it, you travel from here to Delhi in 1 hour. Okay, so it's don't take it for granted. If you want to know the science and technology behind it, it's stupendous. It's simply stupendous. Okay, so this entered Soviet Air Force in 1985. Now India also has this aircraft. This is a fighter aircraft in which plenty of technology has gone in. Okay, and then we'll go to space. orbiter spacecraft. Now the spacecraft speed is orders of magnitude higher. Okay? 17,500 miles per hour. Multiply with 1.6. You'll get how many kilometers per hour. And the price is $500 million around. It goes around the world in 1.4 hours. Okay. This travels, the earlier one traveled 3,000 kilometers in 1 hour. This travels around the world in slightly more than an hour. So this is a spacecraft. You see that tied to rocket boosters over there. The main tank is the what you see in brown color. On top of it, the orbiter is resting now. Yes. So we'll go to the other thing. I don't want to take a lot of your time, but what you see here is an aeroplane. Okay. Commercial aeroplane. So immediately, some of you may have the question in your mind. What do these engineers at aerospace engineering companies do? What do they do? What will I do if I become an aerospace engineer? Well, what do? They have to figure out every step from takeoff to landing of an aeroplane. They can agonize over everything that will ever go wrong. See, you are traveling at such a high speed. In the mid-air, your passengers are sitting near gallons of fuel. Blades are spinning at very high RPM. And one small mistake can be disastrous. So they have to calculate everything using the knowledge that they learn and test it. Testing is very important because lives are involved here, and nothing is more precious than human life. Aerospace engineers are at the forefront of advances made in many engineering fields. I would say, I'll go one step further and say that aerospace engineering is actually the place, is the confluence of all the advanced engineering fields. They are the forefront of research, design and development of high-speed transportation vehicles like airplanes and spacecrafts. And many of the discoveries made in aerospace technology finally filter down and come to our daily activities. For example, when you're looking at Google, the Google Earth, you're actually looking at what was once considered for the military using aerospace engineering. And we are concerned with the design and dynamics of operating a flying machine within the atmosphere, which is aeronautical engineering, if you want to call it strictly. And when you say astronautical engineering, we are concerned with flying machines that operate outside the Earth's atmosphere, such as rockets, missiles, satellites, and other spacecrafts. So if you have a degree in aerospace engineering, you'll be covering both these aspects. Actually, if you are doing astronautical engineering, you have to know the basics of aeronautical engineering anyway, because a rocket and ballistic missile first have to cross the atmosphere before reaching space. The dynamics of operating machine in outer space is quite different from flying an aircraft in the atmosphere, because there is no force, no aerodynamic force or air force acting on it. Okay. Now, aerospace engineering requires the integration of all crucial branches of engineering or technologies. Whether you want maintenance or right from design, the scope for error in aerospace is almost nil. That is of the order of 10 power minus 8. 10 power minus 6 is 1 in a million. So this is 1 in 100 million. That is the kind of error we can tolerate in aerospace, because we're dealing with extremely crucial aspects which have to work in tandem with everything else, synchronize with everything else perfectly. Okay. So something is, yeah. Now let's look at emerging trends in aerospace engineering. Many of you will have some questions here, so let me try to answer them. One emerging field is unmanned aerial vehicles. So the global, it's called UAV. UAV means unmanned aerial vehicles. Now these vehicles can be, very small or very large. The smallest maybe, are called nano air vehicles. Nano, so the size of mosquito or something which weighs less than 50 grams. Some may weigh even milligrams. Some are talking about even dust size, aerial vehicles for spying. All the way up to a fighter aircraft, which is unmanned. It's called remotely piloted aircraft, RPA. Okay. So between these, you have various categories of sizes in unmanned air vehicles, various weights. The advantage of unmanned air vehicles are you don't put a human at risk. Okay. So they are very suitable for such roles. And this is a growing field. In military, you can see the figures here. The projected value of this market, military market, is 26.8 billion until 2025, and commercial is 12.1 billion. It's a lot of money. Now, some of the military uses of unmanned aerial vehicles, surveillance, then unmanned combat aerial vehicle, as I told you, fighter aircraft, then delivery of medicines or supplies to soldiers in distress. They may be in places which cannot be reached by others very quietly. Then PTA means pilotless target aircrafts for testing missiles. You want to test whether the missile is targeting the aircraft properly. You need to have some aircraft flying in the first place. And for these, unmanned aerial vehicles are very suitable. They are called pilotless target aircrafts. Right? Then you can have swarms of UAVs communicating with each other to perform a complex task together. One may see, it is very useful in reconnaissance and doing some multiple tasks. The applications are too many in this area. And another area of interest is you're combining manned vehicles and unmanned aerial vehicles to act as a team. Okay. So these are military uses for unmanned aerial vehicles. Then civilian uses or again surveillance. For example, surveillance over a mall or surveillance during a meeting, surveillance for VIPs. Then broadcast. If you want to broadcast some important news, you can use of unmanned aerial vehicles and very effectively. Then we have agricultural drones for precision spraying of pesticides or fertilizers in agriculture. In foreign, agricultural aircrafts are very common. They have hectares and hectares of land where they use manned agricultural aircrafts for fertilizer or pesticide spraying. In India, we may not have such a large field, but we can use these drones neatly programmed. They will precisely spray the pesticide or fertilizers in areas where you want. Then deliveries of medicines, groceries, and other cargo, we can use unmanned aerial vehicles. Then temperature check in terms of COVID. The next area of development is actually related to your sustainability. See, anyone working in aerospace sector will immediately say, we acknowledge that one of the main culprits for global warming is the aerosol emissions of fuel exhaust from aircrafts. Okay. So now in future, we want to move away from these conventional fuels, which actually pollute the atmosphere. So we are looking at alternate methods of propelling the aircraft. So one of the options is solar aircraft. Others are electric aircraft. Then we have other types of aircraft. Fuel cells and hybrid aircrafts are also there. Then right now, some biofuel is being added to regular fuel to reduce the contaminants in the exhaust. So the solar aircraft utilizes solar energy, and we need to reduce the weight of the aircraft for it to increase its performance. All this is very complex actually. All these are intertwined with each other. Your weight or performance or engine you select, the wing you select, the shape of the wing, shape of the tail, where you should be put the weights. All these are interconnected. Okay. So this nanocarbon fiber are very lightweight but very strong structures. Then another field of which is growing nowadays is structural health monitoring. I'm not a structural person, but I can relate to you what it means. It's more of electronics. Okay. So this will keep track. See, in aircrafts, the cracks may develop inside the metal. You may not even see it visually. And periodic checks are made to ensure, but even within that, you need to constantly monitor the health of every component. This is done best with electronic systems. So, and then one of the important, another thing, last point here is self-healing of aircraft structure components. If something happens, then some components can heal themselves. Okay, that's very, astonishing to some people, but yes, that is one of the key technologies which people are talking about and doing research. Then advances in materials are also another important aspects. New materials like graphene and carbon nanotubes to make lightweight airplane wings. So if you make the wings light, you reduce the load, reduce the total weight, you carry less fuel. There's so much benefit reducing the weight of an airplane. Then there are other materials called metamaterials. So this is interesting property. Normally, a material may not have a property, but by carefully designing the structure of the metal or material, the structure, either in the microscopic level or the macroscopic level, these materials can absorb, reflect, or modify your acoustic signature, electromagnetic signature, and even optic signature. So this is mostly used in stealth technology, where your plane can be made almost invisible because of the materials you use. Invisible to radar, sometimes invisible to naked eye also from some angles. Okay. Then manufacturing also, we have smart automation, then additive manufacturing, which is called 3D printing, to produce lighter and stronger parts. So to produce these parts very accurately and very reliably, we have to go to this advanced manufacturing process. Then one more important area which is concerned with, which is really UAVs. Okay, the technology behind this urban air mobility is going to be unmanned aerial vehicles. This urban air mobility. So to move people from one place to another within cities or across cities without a pilot. Okay, and using technology such as electric propulsion or solar propulsion. So you can imagine air taxis and cargo deliveries through MAVs. Imagine you don't want to go to Tirupati but want to get Tirupati laddus on your table. You order and an MAV flies into your room carrying the laddu after some 2-3 hours. Okay, I'm just giving you a very random example, but you can think of such applications. Now, aerospace engineering principles drives advances in other disciplines also. These disciplines are aerospace engineering. So the relation is both ways. For example, in electrical engineering, wind turbines have turbine blades and structures for which contribution from aerospace engineers are needed. Then in material science, Aerospace engineering drives research in composite materials. We'll be talking more about composite material. Let me take a slight diversion here. These composite materials are extremely, lightweight and extremely durable. Okay, a lot of we specifically make it for a certain purpose. But the problem with these materials is recycling. Once you make it, it's very difficult to biodegrade it. So people are now initially they look at performance and made everything out of composite materials. Now people are looking at materials which can be as strong as composite, but still can be biodegradable. Okay. Now in civil engineering, we'll have, if you have installed structures, then you have to worry about aerodynamics around that. Smart structures, self-healing, etc. will take from aerospace engineering. Self-healing structures, again, the drives from aerospace engineering. Then in mechanical engineering, you'll have gas turbines and automobiles. All the turbo fan and turbo jet engines get their thrust from aerospace engineering. In biomechanics, aerodynamics are used to study insect flight and bird flight. These are the same equations which govern the your MAVs, UAVs, aeroplanes, ornithopters. Ornithopters are flapping machines like birds. In computer science, because solving these problems computationally for aerospace engineering needs extreme power of computing. So this has driven these computer science people to devise new ways of dealing with such high computing power, like parallel computing, distributed computing, and cloud computing. In electronics, avionics is exclusively meant for aerospace engineering, for aviation. Aviation electronics is avionics. Then radar technology is driven by aerospace engineering. Even in naval architecture, the design of hulls, sailboats, and submarines, those designs are very similar to gliders. And we do have, seaplanes, amphibious planes. The submarines are underwater, airplane is inside, inside the atmosphere. But many of the equations and the way we deal with it are similar. So this also drives advances in other fields. So well-trained aerospace engineers should have a broad-based understanding of several engineering disciplines related to various aspects of aerospace systems. And I shouldn't take much time, but let's just quickly go through the curriculum we have at Amrita. This is a well-designed and well-thought-out curriculum. We keep revising it every 4 years on a large scale and every now and then on a small scale. We are always, we have 1 year to the ground listening for advancements in the subjects. So one branch of aerospace engineering, aerodynamics. One important branch is aerodynamics, where you study all these subjects. The left-hand side are mostly, core subjects. You have to study that. On the right-hand side, you have electives, which you can choose to study if you want to specialize in aerodynamics. Same way for aerospace structures. The left-hand side, mostly it is compulsory or very mandatory courses which you should know. On the right-hand side, you have electives or, something which is of the higher order. Propulsion, similarly, you'll have propulsion is the science of, how to propel the aircraft forward. Roughly speaking, engines, but you can have other types of propulsion also. Okay. Then control systems, how to steer the aircraft. Steering is a control in your car. Similarly, we have other controls in aerospace system like joystick, rudder, then elevator, rudder, ailerons, such parts. So the branch dealing with this control theory, and it's also known as flight dynamics. Okay. Then we have design, where you have to put everything together and come up with a design. So we have an aero design course and flight mechanics course closely related to aero design, because after you design, you have to test the performance of your aircraft. Whether before or after design, you have to learn flight mechanics, how the aircraft flies, and how can the performance be improved. Then you have other design related electives, and multidisciplinary courses and electives also. And careers usually will involve research, design, and creation of new aircraft, missiles, etc., maintenance of these, sometimes weapon systems, and also the components of these. So on a typical day, aerospace engineers may use scientific principles and computer-aided programs to design some components, or you may supervise some assembly of airframes at a later stage, or participate in flight test programs. Once it's designed, how to do a flight test, and some may be flight test pilots. So after aerospace engineering, the student may join aerospace engineer in civil aerospace companies such as Boeing or Airbus. Some of our graduates have joined there, quite a few, in India and abroad. Then airworthiness officer in DGCA, only a couple of people knew about that at this point of time, so many did not apply. A couple of people have joined there. Then we have students who have joined DRDO, ISRO, CSIR. That is, CSIR is lab for CSIR labs are well known. They are all over India. You can become a technical communicator if you are interested in communication and English. If you want to physically put your theory to practice, people have joined Air Force or Navy. Navy has its own aircraft squadron, or there are many who have gone for higher studies, to pursue higher studies in aerospace, because they want to make themselves better in the job market, or according to their passion, they're pursuing higher studies in aerospace or related disciplines, and in very eminent colleges, both in India and around the world. So these are some of the companies in which our students have joined. It's not an exhaustive list. There are many more. Not able to put everything in such a short time and slide. Airbus, GE is General Electric Company, then Rolls-Royce, Mercedes-Benz, Eaton. They are CFD company in India. They're basically a British company, but they have a branch in India. Then, of course, ISRO, DRDO. In locally, LMW. Now, government is, giving projects to private companies. So, private companies, LMW and L&T also offer jobs to aerospace engineers. Quite a few of our graduates have joined there also. Then this is MADS is related to air traffic management. This is there in France and other European countries. People have joined this company also. And thank you for your time. Sorry, I couldn't go through in much detail, but because of lack of time, I think I have to stop already. I think I have taken a lot of time. Sorry for that.
No, completely fine, sir. So thank you so much, because you have covered, I think, sir, you can just stop sharing the screen.
Yeah.
Yeah. You have actually covered a lot of details related to what is actually aerospace engineering, about the different sectors where the students will be working, about the different positions, the career opportunities and all. And also the basic divisions also, somewhat the subjects also, the areas also related to aerospace engineering. So we have actually a lot of queries in our chat box. I would we'll directly start addressing them. So the first question is from Yashaswini. It is, what is the difference between aeronautical engineering and aerospace engineering?
Okay. I mean, technically, you would say that aeronautical engineering, this is concerned only with the atmosphere, the vehicles which move inside the atmosphere, like aeroplanes and UAVs. But when you say aerospace engineering, we are also bothered about the flight outside the atmosphere. How do you take a satellite to its orbit? It's through a satellite launch vehicle. which is going through the atmosphere and also travels in outer space. And aerospace will also cover how to basically, or what are the laws governing the motion of planets around the sun. Everybody knows from 12th standard, they know this Kepler's laws govern these things, Newton's laws. But then why is it so difficult to apply these laws to practical situation? If you imagine to launch from Earth to a Mars, for example, it's called interplanetary transfer. Okay, so you have to launch it in such a way that, imagine, Earth is also going around the sun, not in a perfectly circular orbit. It is in a slightly elliptic orbit. The speed will also vary. Same is true of Mars also. When you launch a satellite from here, when you reach there, Mars won't be there where you saw. It will be in some other position, the opposite direction. So you have to predict very crucial, very accurately where Mars will be when you are moving your satellite there. So it becomes more complex. Things like this will be addressed by aerospace engineering. But basically, most around, I would say 70% of what in aerospace engineering will have commonality with aeronautical engineering. An aeronautical engineer with very little additional knowledge can study aerospace engineering at a later level. Having said the difference, I'm also telling that the difference is not insurmountable. If you take aerospace engineering, then you will probably cover this at an earlier stage in your career. That's the main difference.
So thank you, sir. I hope that question is clear. Now we have another question. Is coding necessary in aerospace engineering?
Coding, it is basically how you want to evolve. If you are good in coding, you can follow a path in which coding is very essential. Computational fluid dynamics, or you use computing for evaluating structural elements, how much load is coming, what is the strength of thing. If you're using computers, you have the choice of coding. But if you don't want to code also, you have how to use the software to get your thing intelligently done. Then you don't need coding. You may have to know how to use the software. I'll go one step further. If an experimentalist, you don't even need to use software. You need to use them when you study. When you go to work, if you're designing an experiment, you know the fundamentals of the science governing the experiment and how to design it. That is a separate art by itself. Experimental aerodynamics, experimental testing of various components of aircraft, acoustics testing. So it depends on which path you want to follow. So the answer is yes and no. Depends on you, find it. Depends on the student who is trying to follow.
So thank you, sir. There is another question. What is the probability of AI taking over the industry of aerospace engineering? Can AI replace such aerospace engineers?
AI cannot replace aerospace engineers, but it can make their job easier. I would say aerospace engineers are facing such a gamut of problems that they are gasping for breath. Please let someone help me. And their AI can help. But even then, AI can only help to a certain level. Because AI is basically, it can do only what is trained to do. It can use the knowledge which is there in the world, but it doesn't have the intuition of a human being. The intuition is very much necessary for many of the positions in aerospace engineering. So, in my opinion, AI can never replace an aerospace engineer, but the aerospace engineers need to get themselves trained in AI because they can do the job better than others and can move forward. So there's no risk of losing job because of AI. But we have to continually sharpen our skills in the allied fields. Does it answer the question, madam?
Yes, sir. So another question is whether simulation is also covered in this branch.
Yes, definitely. Simulation is also covered. We have a separate field called flight simulation. We have flight simulator lab also. You might see in the video some, one instructor teaching a student how to do that. It's not like just like you're, playing a flight simulator game. You also have to record what is there and see whether, how much performance it's done, and it's slightly more serious than playing a game.
So there is one more question. Will there be anything regarding practical rocketry in the course of co-curricular activities?
Practical rocketry.
Rocketry. Yeah.
Yes, this we give to the students open lab. When open lab, we mean that initially we take them through the basic labs in the first half of the lab. The second one, we let the students decide what they want to do. So they design their own experiments. As a part of this, you can use rocketry, and we have many rocketry events in Anoka. Earlier events of Anoka is our tech fest earlier. So we have had teams participating in this water rockets and other fun activities. So you can learn about rocketry practically if you want to. But the initiative is on you. We don't teach it exactly here. That has a separate, in masters, I know in BITS Mesra, they have an opening for exclusively for rocketry. And many of our students have joined this. So the basis you get here will take you there if you're very much interested in rocket. They don't have a BTech in rocket. They have only masters, but they welcome students with aerospace background for that course.
There is a question. I am passionate on designing or inventing aircrafts. What
Yes.
I have to prefer, whether it's aerospace or aeronautical?
Aircrafts,
Yeah.
not
Designing.
spacecrafts.
Designing.
See,
Yeah.
you can take either one. It doesn't mean that you take aerospace, you get less of aero design. Basically, it's design, and design is an art. In any field, when you want to design something, it's an art. You need to have the experience. You need to know what are there in all the fields. You should know how to put them together to achieve your end. You should be given a kind of specification. What do you want? From there, you start. Finally, design something and test whether you got what you wanted. So I would say whether you take aeronautical or aerospace, you will have aero design. You won't be interior anyway.
Now, sir, students are asking about the internship opportunities during our aerospace engineering at Amrita.
Okay. Internship opportunity, we support a lot of internship opportunities. Many of our students are going to HAL, NAL this year, and many DRDO labs for internships. We try to make it a bit mandatory after the third year. Before that, in their holidays, they can go. During the semester, they will be missing more important things here. So we don't really encourage that. But if it is a very good institute or very high, very reputed organizations, we do allow.
Is it possible to pursue commercial aviation after doing BTech in aerospace engineering?
Yes, but you should be aware that we don't teach how to be a pilot here. There is a different ball game. You need to physically do many things. Here, you will be at an advantage if you study aerospace compared to other people. Other people can also become pilots, but when you become a pilot, when you go through that separate course, you will understand things better if you're in aeronautics. You will understand how the aircrafts move, what you should do, even before others know the subjects. That is one advantage. But we don't train you to be a pilot. We train you rather how to make an aeroplane and the allied sciences and technologies behind that. How to make an aeroplane or a spacecraft.
Now, another query is, what can be the market for aerospace engineers after 4 years? Maybe after 4 or 5 years.
Yes, actually, I know this is a very relevant question. I appreciate the person who asked this question. Throughout the years, aerospace I'm telling very openly, I want the students to benefit. So don't get me wrong. I am telling you, aerospace engineering historically had people say there are very few jobs in aerospace, very few jobs. But no, there are jobs in aerospace engineering, and these are going to multiply. Why? Especially in India. Because in India, the government is inviting foreign companies to set up offices here, and at least 50% share should be given to private companies here. So in the private sector, both aeronautical and space companies are going to see a jump. This was not there so far. So far, we are going only for after government jobs or government related activity or research jobs. Now all this is set to change because of this push given by government, and also because of the budding field UAV, unmanned aerial vehicle and unmanned aerial systems. Now this is growing like mushrooms, mushrooming everywhere. Now we have a lot of scope in this area. So I would say down the line, definitely we are seeing now that we are seeing signs of that even now. The opportunity for aerospace is getting better and better. Down the line, after 4 or 5 years, I'm sure that the market is only going to get bigger. The main difference, let me answer one more before they ask the question. Okay. If you compare with computer science, I don't want to compare, but the mindset of many people, so computer science will give me a job with pay you lakhs and 10 lakhs, 15 lakhs, 20 lakhs. Sure. But 1 year later, the market goes down, you won't have a job. That is also very much possible in computer science. Today, you may have a very good job. Tomorrow, you may not have a job. But aerospace engineering, it takes some time, I should say. After your BTech, if you do a master's, you'll get a better job. And it takes some time to get a good job, maybe 1 year or 2 years. Initially, you will get a job. But if you persist, you will get a job. And that job will not be unstable. It will be a stable job. And you can steadily grow. At the end of your retirement, if you look at a computer science guy and yourself, you won't need any job. Okay. So that is the students to take, whether they want this kind of career or they want that kind of. I am sorry for being blunt. I can't hide anything. Sorry.
No, it's actually everybody agrees that nowadays people are behind the computer science, and even every student is only hearing computer science. Those
Yes.
are really into the keen into the, I would say, the other branches or the core branches. They are only looking for that details.
Correct. But this is a very exciting area where you can even computer science can also join. See, if you look at people hired by ISRO and DRDO, they are not only aeronautical. In fact, I would say they take in more of computer science people and mechanical people and teach them aerospace after they join. Okay, but the private sector is going to change all that. They would need aerospace engineer right from the start, and that is going to boom.
And there are a lot of students who are already asking the query, is it really important to do masters in aerospace engineering?
I would say it is good to do, but because the field is so vast and you have to be ahead of your competition. So there are two ways of doing it. One is do masters immediately after your BTech, or if you join a job after your BTech, you can, with your employer's consent, you can do it part-time, or after gaining experience, you can do masters. This you have to do in aerospace. This is called continuous learning, lifelong learning. Not only in aerospace, it's true in all branches of engineering now. That is where, if you want to be abreast of others, you should learn AI, you should learn ML, because it's a peripheral aspect of aerospace engineering, not the core. But you should know what is happening in the outside world. And learning, if you get a degree also alongside, you get more recognition. So it's better to do a master.
Now, even we have queries related to UAVs. So how are aeronautical engineers contributing to the design and operation of drones and UAVs for the different applications?
Yes, drones are basically unmanned aerial vehicles. That's what I was talking about. So aeronautical engineers will design the shape, the wing, and how much payload it can carry inside. So the payload itself may or may not be done by the payload may be a camera, okay, or some food supply or pesticide. This may be from another person, or cargo, which is another person. But how to carry it, the design of the whole airplane is done by aeronautical engineers. Yes. In some ways, it is simpler. In some ways, it's more complex. The challenges are slightly different between manned aerial vehicles and unmanned aerial vehicles, which are drones. They have their own advantages and disadvantages. But most of the technology is common. Most of the technology is common. So yes, aerospace engineers are driving advancements in unmanned aerial vehicles.
Sir, actually, students are asking about the universities that our aerospace departments are having a tie-up with.
Here, okay. That is with abroad?
Yes.
Abroad, okay. So I don't remember the entire list, but I know students who have gone to these universities. That's why I know the area. I do have it. One is University of Milan, Italy. Italy, there's Polytechnic University. There people have gone. And Valencia University in Spain. Then University of California at San Diego. San Diego or Davis. University of California at Davis in the USA. Then people have gone to Michigan State University. Then KTH, Sweden. These are some of the universities I can remember where my students have gone earlier. There are more, but I can recollect only these few now.
Now, there is one more question. Do we have the student exchange program also for aerospace engineering?
Yes, people have gone in their third and final year. Even in this current set, around 3 to 4 people have decided to go for a, as I told you, one to Valencia, then one to this Milan, two to Milan. Two are going to this to Milan, in Polytechnic University in Milan. And there is one more who went to, I forgot the university name, University of 20 years in Poland.
So, sir, there are questions related to carbon footprint also in the chat box. So,
Yes.
it's like what strategies and innovations are being employed by the aerospace industry to address the environmental concerns and reduce the carbon footprint of aerospace?
Very good, very good. As I told you, we are one of the main culprits for the air pollution. So one initiative is going for alternative propulsion, like solar, then electric, then hybrid, and fuel cells. All these will actually bring down your carbon footprint. That is one way of tackling it, through propulsion. Then through aerodynamics, we design structures and wings which consume less fuel. Like for example, very streamlined bodies can glide through air very efficient. So you need less fuel to get from one place to less power. So this is another way. Third one, the materials which we are using. As I told you, for high performance, we are trying to use these composite materials, which are not environmentally, and they cannot be biodegraded so easily. After they are there for 20 to 30 years. And interestingly, even in renewable energy, they are facing this problem. For example, in wind turbines, there is actually electrical engineering, but because aerospace engineering has a tie-up with directly with wind turbines, I'm going that area. The wind turbine blades are made of composites. They are made to last for 20, 25 years. Now, many of the blades made earlier now have worn out. Where to dispose them? That's a problem. People are now thinking of wooden turbine blades. They want to go back to that future. Now the challenge is, now we have to design things in such a way that we have to look at them in the whole cycle, whether from the initial to the final disposing of the element, your process is carbon friendly. I mean, for making a non-renewable energy source, you shouldn't use renewable energy. Sorry, for making a renewable energy source, you shouldn't guzzle up the already existing coal and other deposits. So that total carbon footprint reduction is to be taken seriously. I'm actually encouraging my students to study this aspect during their design. They are giving design projects where this is one of the main concerns of future.
Sir, there is one query. It's like,
Yes,
how does Amrita support the students in their career development? They want
Career?
to career development. They want to know about the placements, maybe the trainings that we are providing, and about the jobs. And
Yes. So career, basically, we have a CIR here, Corporate and Industrial Relations, which actually looks after the job placement. And there are aerospace related companies which come for campus placement. One Dassault Systems is coming. Then there are a few other companies. Otherwise, the faculty in our department know people in other, ISRO and DRDO, they have tie-ups. They talk to them. They get them some initial training or internship opportunities. After that, they join their company. There have been many instances like that in the past few years, where the faculty are actually helping the students to secure jobs. They will have both the items in mind. The student should fit the job. Okay, the student should be of benefit to the person whom they are recommending to. I'm telling this because you should work hard after you join. Aerospace engineering is not a cakewalk. You have to work hard because it's a really probably one of the toughest disciplines to master. Yes, ma'am.
So is fuel chemistry included in aerospace engineering?
Can you repeat, madam?
Is fuel chemistry included in aerospace engineering?
Again, if you want to do that, you can take that combustion, one field of propulsion. But in general, no, you don't need it otherwise. If you want to specialize in that, yes, aerospace engineering has space for everybody, I would say. If you don't like it, don't be scared. We have a lot of other opportunities. If the purpose is whether you like it or not like it, either way you can join aerospace.
So there is one more query. What are the chances of going for masters as aerospace after finishing some other branch in UG? People have written it's a query
Yes.
from different candidates, computer
Yes.
science, electronics, or AI.
Yes. They have to write the GATE exam for aerospace. There are, as you told, there are in civil engineering, if you study civil engineering, electrical and electronics, computer science, or mechanical engineering, you can write aerospace engineering GATE paper. If you write that GATE paper, you can compete with other aerospace students. But in general, the one who studied aerospace will have a small advantage when you go to masters because he will know most of the basics already. It is possible to say. It is possible to do master. It is possible. Yes.
I could see queries in the chat box. Can I come and visit your department? Please do understand that all the campuses are open for the students and the parents and everybody to come and visit. Even you can go to our labs, understand what all facilities we have. So there is no need to ask this question. You can come on working days between, I would say, 9:30 to 4 p.m. Okay.
Yes, you're most welcome. You're most welcome.
Yes. Students, I think we have the last 5 to 10 minutes. There are students are typing in the chat box. Please ask my query. Ask my query. There are a lot of queries that's coming. So it's just so fast that I'm not able to collect everything. Okay, there is one query. Can I become astrophysicist after studying as aerospace or astronautical engineering?
Yes. But then you again, just like pilot, you have to undergo a different field of training. There are quite a few astronautical engineers who are aerospace engineers. Quite a few of them. Yes.
Then students, if you have any queries, you can start posting that in the chat box. Okay. Will I be okay about becoming an astronaut? That questions is also coming from student side. How to become? Yeah.
How to become is, it's again a different field which involves a lot of physical training in addition to your, technical skills. A part of what you learn in aerospace will be important there, not everything. Then you'll be given specialized training to become an astronaut.
Now, another question is, yes, I think sir has already covered details related to the job opportunities and current scenario. I'm not that much good in physics. So how important is physics to aerospace engineering?
I'm sorry to say it's very important. Very important. If you're not good in physics, I would say, honestly, try for some other. branch, because it is very, very important, at least mechanically. If you don't know electricity or magnetism, still we can forgive. But in physics, there's a branch called mechanics. You should be very comfortable and interested in mechanics, at least in mechanics, in physics. Otherwise, it will be very difficult. I'm telling you. So I'm just giving you all the important.
Another question is, do you support children in participation in the conferences, competitions, or events? Maybe whether it's included in the curriculum or if it's external. In both the cases,
It is external. It is external, but we do encourage. We do encourage. Even recently, one of our teams won first prize in UAV competition. They won 1.5 lakhs prize, the team. So, I mean, we are overjoyed that in international competition, they won the first prize.
So there is one query related to the same thing. How much reliable are the UAVs?
UAVs reliability. See, this is a very open-ended question. So let me, when you talk about reliability, you first see for what purpose they are designed. If they are designed for a very simple purpose, then there is no need for reliability. If you want it to be more reliable, obviously it will become more costly, exponentially costly. Okay. So if you want it to be very reliable, you can make it. If you want a precision bomb to be delivered at an exact location, like our very brave soldiers, okay, have used these UAVs from aircrafts to bomb exact locations, enemy countries, okay, and without loss of civilian life, they have accomplished their aims, okay.
And
So,
do you help mechanical engineers do research in the aerospace fields?
yes, mechanical engineering is very closely related to aerospace engineering. So,
yes, I think mostly they are concentrating or talking about the interdisciplinary things that's happening there.
yes, a lot of interdisciplinary activities are happening in aerospace. Aerospace, by its nature, is interdisciplinary. It is a confluence of many fields. The basics are what the four I told you: flight, that control systems from electrical electronics, then aerodynamics and propulsion from mechanical engineering, structures from civil engineering, and there are others, computers from everywhere.
Sir, actually, some students are requesting to give them permission to talk. I think we can do that. Okay. So, Maitreya, I have given you permission to talk. Can you please unmute and talk?
Good evening, ma'am. Good evening, sir. Thank you for
Good
giving the opportunity to talk. This is Maitreya's mother. My son is very passionate ever since he was 7 years to get into aerospace engineering. So we just wanted to understand with the kind of, the way the market is opened up for the private players as well, and the in-space programs that's run by ISRO. We just want to understand what is the scope of aerospace engineers and the career way forward, especially in terms of the companies that are absorbing, and then the future, in the sense, further education and the career growth, because we have seen, I myself IT person, we somehow don't want to get there because of the kind of risk that is involved, and the actual core engineering branches are avoided, basically, for lucrative opportunities. So we want to understand, because nowhere at any point of time we should be able to feel that we made a wrong decision. So we just want to understand, because this is once in a time opportunity to understand things.
Yes.
Thank you so much.
What I would say is, whether it's IT or non-IT, if you have the passion, you can shine any field. Same is true for aerospace also. You should have the passion in you. If your son has the passion, like he says, I would welcome it. Definitely, please come in. So the opportunities, as I told you, looks like they are going to multiply in the next decade. Especially when private players are coming into picture, there's going to be a boom. I can see that for aerospace engineering, but not in the fields, the traditional fields. The traditional fields will be there, but the growth may be in these UAVs and the privatized defense and space companies. And then career growth, again, it will be slow but steady. Usually, it doesn't involve such a high risk, because it is not a field where the market changes every 6 months. The market change will happen over a period of 5 to 10 years time. You can predict what's going to happen after 5 to 10 years time with more certainty than in computer science. Does it answer your question, madam?
Yes, sir. Partially. I'm not sure if we have further time because we want to go for post graduation as well to get into the area of specialization because it basically
Definitely.
wants to get something like an astronaut or
I would
something.
say,
Or
I would say if he's
aerospace.
passionate, please, if he's passionate, please encourage him to join aerospace. It is a good field.
Yeah, and also if you're based out in Hyderabad, so we do not have any opportunity to come and look at your labs and all. So that's how we are, expressing our curiosity to understand more about this.
Okay, okay.
So
Yeah, I understand. In
I want to
Hyderabad, yes, many of the students come from Hyderabad.
right. So I want to
That's
understand
like,
the companies which actually give us an opportunity for them to expose themselves and expand their knowledge and vision, so that they can choose a career path and go forward in their post graduation, and then
I would say, our Indian universities have become as good as any, foreign university now in terms of standard.
yes, sir.
If you look at IISc, the IISc citations are now citation wise, it is ranked even better than MIT. In that, it is now the world's best university in that citation aspect.
Okay.
So the way to enter these universities is through GATE exam.
Yes, sir.
And if you study well and score well in GATE, you have a very good opportunity to land in a very good career. Even in fact, this time, one of our students got the All India 6th rank in GATE. We're proud to say that. Every year, quite a few of the students qualify GATE and go for higher studies. And this year, we got the 6th rank, All India 6th rank. Earlier, we All India 1st and All India 2nd also were from our department. In our earliest. Every year, we have this, I shouldn't, be very proud and say, hey, I did it and everything, but the
That's an
students do it.
accomplishment.
The
Yes.
students do it. So,
So
we
usually
welcome
how
them.
long? So usually how long does it take for an aerospace engineer to properly settle in his career?
I would say, it's a never-ending field. See, you have to keep on learning. Even now, I will say that I'm still learning.
Yes.
A lot of things which I don't know. So settle means, what do you mean by settle?
In the sense to pursue the kind of different other branches, like for example avionics or any other thing, because I'm not really good at that.
That you can do in masters.
Okay.
In masters.
So I hope the job
by
market.
Masters, you can specialize.
Okay. So I hope
If
the
you
job
want to
market is good enough to for such opportunities.
See, it depends on, if you take avionics, for example, yes, you can get electronics jobs also. If you go to aerodynamics, then some part of mechanical jobs and other things. So it depends, highly depends on the field you pursue after aerospace. It's a very broad-based course here. So we do have electives, but we suggest people should take up masters so that they can specialize for what they want.
So that guidance is given by you, sir?
Definitely.
Sure,
We
sir.
do guide, yes. All of my colleagues will guide any student. Any student can walk into a cubicle and ask for advice. We never say no.
Thank you, sir. So can we reach out to you in person since we're out of Coimbatore?
No problem, madam. My email, madam will give you my email. You can email me or call me anytime. No issues.
Sure, sir. Thank you, ma'am. Could you please share the details?
Yeah, I'll do
Thank
that.
you so much,
Thank
ma'am.
you so much. Yeah. So, sir, I think one more person is there. It's like 5 to 6 times. He's actually, I'm just going to give him also permission to talk.
Yes.
So, Siddharth, I think I have given you permission to talk.
Yes, ma'am. Namaste, sir. I just had a really
Namaste.
curious doubt because I'm really passionate about everything related to space or like aerospace engineering, and I just wanted to know, like apart from all the practical stuff that is there at Amrita, sir, is there any scope for me to go for theoretical space, something like astronomy or astrophysics after this?
See, if you want astronomy or astrophysics, I would suggest you talk to madam about how to get to integrated physics. That will deal more with astrophysics or astronomy. So, Lakshmi madam can guide you on whom to contact. The admission process may be a bit different for such branches, may not be through your exam you take. Okay, so the branch which deals with that is not aerospace in Amrita. It is astrophysics and astronomy with physics department. MSc Integrated Physics, there is one course. You should look for that course if you're interested in these fields.
Yes, sir. Thank you so much, sir.
Thank
Sir,
you.
also, is it okay if I can get your personal contact, sir? Because I have like a lot of doubts and we are running short
Yeah.
on
So,
time.
you
Just
can
a
ask
second,
madam.
sir. Yeah. So I have provided one mail ID in the chat box to everyone. Whatever queries you are having, you can just mail to that. We'll just give you the replies, and that replies will be formulated from the faculties of the respective department.
Yes, give me
So
a
I
day
have
or
given-
two to, give me some time to react to that because I have other duties also. I am
Correct.
sure I'll
Don't
get
want
back
to
to you
keep
in 2
everyone
to
else.
3 days time. Yeah.
So yes, I have typed the mail ID, and I hope you all have got it. So thank you so much, sir. I think we have
Thank you.
covered more time also. It was really wonderful, and there are a lot of comments also. We were
Thank you
able to
very much.
hear a lot of queries from the students. So
Thank
really
you. Always,
happy.
we are there to help students.
Yeah.
What else is this job for?
So thank you so much, everyone. And I hope this was useful. Have a very good evening and have a great day. Thank you so much, sir. Thank you so much.
Thank
for
you.
your
Thank you
time.
very much.
Yeah.
Thanks a lot.
Thank
Thanks.
you. Thank you all.
Can I leave now?
Yeah, yes, sir. Yes, sir.
Thank you.
Completely. Thank you, sir. Thank you, sir.